So it kind of got cut off there. Computer went dead. Got to plug it in. All right, so anyway, what we want to notice here is that we've got all the information we need here, but this is missing the slant height. But we have a right triangle, Pythagorean theorem, hypotenuse, 6 squared plus 8 squared equals c squared. That means 36 plus 64 equals c squared, which means that 100 equals c squared, and 10 equals c. That's a calculation you have to do before we start. And that's our slant height. Get rid of that c. All right, so our new problem looks just like the old problem. So we begin using the surface area, the lateral area plus base, because a cone only has one base. The lateral area is 1/2 times perimeter times slant height. That's 1/2 perimeter. Perimeter of the base is the circumference of the circle, whose radius is 6. Circumference is 2 pi r, and 2 pi r with 6 in it looks like that. That's our perimeter. And our slant height, we discovered a moment ago, was 10 times 10. That's 1/2 perimeter, which is 2 pi r, times slant height, which is 10. 1/2 times 2 pi r times 10. That's 188.5. We're working in meters. Surface area equals lateral area plus base. So lateral area is 1.5 plus the base. The base is a circle whose radius is 6. So that's pi r squared, where I is 6, or r is 6. Pi r squared. There's only one base. So it was the base plus pi r squared. That's 301.6. 301.6 square meters. The volume was 1/3 the area of the base times the height. That's 1/3 the area of the base, which is pi r squared. Area of the base, the area of the circle, radius is 6, pi r squared, times the height. This is volume, so this is regular height, so that's 8 meters. That's 1/3 times pi r squared times 8. One-third pi r squared times 8, 1/3 base height. That's 301.6. We're in volume, so that's cubic meters. Number 9. Number 9 is a sphere. Sphere is a ball. So we have two formulas. Surface area and lateral area are the same thing. Surface area equals 4 pi r squared. The radius, the diameter is 9. The radius is going to be half that, or 4.5. So that's going to go 4 times pi times 4.5 squared.
4 pi times 4.5 squared. 4.46, 254. Surface area, we were in inches, so that's inches squared. Our volume, so formula that's 4/3 pi r cubed. So that's 4/3 pi
R is going to be 4.5. The same as last time, half the diameter. It's going to be cubed this time. So that's 4/3 pi r cubed. There's 381.7 cubic inches. How many faces, edges, and vertices does this polyhedron have? Faces, edges, and vertices. So we're going to count them. And we use Euler's formula to determine if we're right. So face flat bits. There's one, so that's 2. Then each one of these sides has got there. So there's how many sides? 1, 2, 3, 4, 5,
6 sides. Each one of them has a vertical face. So it's 6 around, 1 on top, 1 on bottom. Faces equal 8.
edges. There's 1, 2, 3, 4, 5, 6 on top. 1, 2, 3, 4, 5, 6 on bottom. And then each one of these corners is going to have another vertical face. So that's 1, 2, 3, 4, 5, 6 corners as well. So 6 edges on top, 6 vertical edges, 6 on bottom, 6 plus 6 plus 6 is 18. Vertices are corners. 1, 2, 3, 4, 5, 6 on top. 1, 2, 3, 4, 5, 6 on bottom. 6 plus 6 is 12. Use our formula to verify. Faces plus vertices equals edges plus 2. So that would be 8 plus 12 equals 18 plus 2. That's 20 on both sides. So that works out. Number 11. Use Euler's formula to find the number of missing faces in a polyhedron with 15 edges and 9 vertices. So that's 15 edges and 9 vertices. So faces plus vertices equals edges plus 2. Edges is 15. Vertices is 9. That's f plus 9 equals 15 plus 2. F plus 9 equals 17. Subtract 9 from both sides. There are 8 faces. 8 plus 9 equals 15 plus 2. A polyhedron has 6 faces and 8 faces and 6 vertices. How many edges does it have? So it's faces plus vertices equals edges plus 2. Said we had 8 faces. So that's 8 faces and 6 vertices. Asking how many edges. So 14 equals edges plus 2. Subtract 2 from both sides. Get 12 edges. Number 13. One summer Saturday, Sennett was lying in a flat field enjoying the sun. His eyes strayed to a tree standing 65.2 feet away. A huge red balloon was caught in the limbs at the very top of the tree. The angle of elevation from Sennett's eyes to the balloon elevation is from horizontal up. is 40.3 degrees. Degrees go inside the angle. What is the height of the tree rounded to the nearest hundredth? So from this angle, we're given the opposite side and the adjacent side. Opposite and adjacent is on Arapahoe. That means that tangent of the degrees was opposite over adjacent. Tangent of 40 4.3. Do a quick check to see we're in the right mode. Yep, we're in degree mode. Tangent 40.3 is 0.848. H over 65.2. Multiply both sides to get rid of the denominator. And multiply 0.848 times 65.2. 55.293. We're supposed to go to the nearest hundredth, so that's tens place, hundredths place. 3 rounds down, 55.29. Number 14 is a parallelogram. We're asking for the area. The area of a parallelogram is base times height. Here's the base, which is the same length as 1.4, so the base is 1.4. Here's the height of the parallelogram, which is 2.3. So the base was 1.4, the height was 2.3. 3.22. We're in square inches. Find the area of the regular hexagon. Go all the way around. We're going to use the formula. Area equals 1/2 apothem times perimeter. 1/2 apothem. Apothem. Go all the way around, that's 360 degrees. So any one of these is 1/6 of that. There's 60 degrees. That's 60, that leaves 120 on the inside, because you subtract from 180. And our apothem comes here. And we're going to find it by splitting that in half. So that coincidentally is 60 again. This bottom is half of a side. A side is 3. So half of 3 is 1.5. So we're given of 60 the opposite and adjacent sides. So that's tangent. Tangent of 60 equals A over 1.5. Find the tangent of 60. 1.732. So A over 1.5. Multiply both sides to get rid of the denominator. .598. There's our apothem. And our perimeter. Where'd it go? It's 3 once, twice, 3 times, 4 times, 5 times, 6 times. 3 times 6. So put it in the calculator. 0.5 times 2.598 times 3 times 6. 23.38. That's